Today we're going to be talking about bonding of atoms and the creation of molecules and compounds. So we've been talking about atoms and elements, so now we're going to talk about how those things form new substances, such as molecules and compounds. So we need to learn, first of all, that there are different types of bonds. The way that we're using the word bond, we're referring to the use of valence electrons to join two or more atoms and create a molecule or a compound. Remember, the difference between a molecule and a compound is that a molecule is when two or more atoms are joined together. A compound is when two or more elements are joined together. So all compounds are molecules, but not all molecules are compounds. So an example of a molecule only would be O2, or two oxygen atoms that are joined together. That's a molecule. It's not a compound. A compound would be H2O, which is two hydrogen and one oxygen, because there's more than one type of element. We need to remember the octet rule, which the primary goal of bonding is for each atom to become happy by filling its outermost electron shell with 8 electrons. Unless you're talking about hydrogen or helium, which only have one electron shell, and so then the most that they can hold is 2 electrons in that shell, but those are the exceptions to the octet rule. There are two main types of bonds. The first is covalent bond, and the second is an ionic bond. So we're going to start talking about covalent bonds first. Covalent bonds occur between two nonmetals. So, for example, hydrogen and oxygen. A covalent bond occurs when both atoms share the electrons. So when hydrogen and oxygen join together, like in H2O, those electrons are being shared between the two of them. So then those valence electrons, okay, will circle both atoms. So they'll be in the electron shells of both atoms. And so after bonding, each atom has a full outer electron shell. And remember, this is the goal of bonding, is to fill that shell. Covalent bonds are strong, and they resist separating. A covalent bond, you can think of it as like gluing two materials together with superglue. Okay, it's a very strong bond. It's really hard to get them apart. So if you can see here in this diagram, okay, so here are your outer electron shells, and you've got these two valence electrons, okay, and they're going to be shared between both shells. So they're going to go around here, sort of like maybe this figure 8 pattern. They're going to be crossing both shells. So here's your water molecule. So here are the shared electrons, and here are shared electrons. So these electrons are going to travel through both atoms' valence electron shells. There are different types of covalent bonding. There's a double covalent bond and a single covalent bond. In a single covalent bond, each atom is sharing one covalent electron. Okay, so each one is giving each atom is contributing one electron to the bond. In a double covalent bond, each atom is sharing 2 electrons. Okay, so here, and in something like water, you know, the hydrogens are contributing 1, and the oxygen is contributing 1 to each of the hydrogens. So those are single covalent bonds. In the double covalent bond, more than one, each element is contributing 2 to share. So here's some other covalent bond examples. So you can have two hydrogen atoms, right, and they're sharing, and so that's a single covalent bond. They're each contributing one valence electron, which is going to be shared between both of them. Okay, two fluorine atoms can join together. Again, they're each going to share one valence electron. So it's a single covalent bond to make F2, or a molecule of fluorine. Again, you're going to have your two oxygen atoms plus two carbon, or plus one carbon, so CO2, our carbon dioxide molecule. So in this one, you can see that there's a difference, because here, each oxygen atom is contributing two valence electrons to the bond, and the carbon atom is contributing two electrons to each bond. So carbon is sharing all four of its electrons. It's sharing two with this oxygen to create a double covalent bond, and two with this oxygen to create a double covalent bond. Okay? We can also have four fluorine atoms plus a carbon atom, which is a molecule of carbon tetrafluoride. And so you can see that there's four single covalent bonds that are being created here. So then I want you to notice that each atom, after bonding, has a full outer electron shell. Okay? Because if you look at this oxygen atom right here, you've got 1, 2, 3, 4, 5, 6, 7, 8. Same, and the carbon has 1, 2, 3, 4, 5, 6, 7, 8. And same thing over here, 2, 4, 6, and then with these two shared ones, it gives it 8. So all of them have 8 electrons in their outer shell. So that's how they can accomplish that, by sharing electrons. Now, there's another way to do bonding, which is an ionic bond. So we need to talk first about ions. So an ion is when an atom's charge is no longer neutral. There are either more or less electrons than there are protons. Now, there are two different types of ions. There is a cation. And this is where we have to be very careful, because it can be a little bit tricky. A cation is an atom that has lost at least one electron. So it has more protons, which have that positive charge, than it has electrons, which have that negative charge. So therefore, it has a positive charge. So you've got to remember that losing an electron, or more than one electron, creates a positive charge. We also have, so here we have sodium, and if you see this, if you see an element written with this little plus sign, that indicates that you've got a cation, that there's some sort of, it has a positive charge, because it's lost at least one electron. Okay, then there's also an anion, which is an atom that has gained at least one electron. And so it has more electrons, which have their negative charge, than protons, which is a positive charge. And therefore, it has a negative charge, right? So more negative than positive equals negative. More positive than negative equals positive. And so you'll see that written as Cl, right? So we've got chlorine here, and we have that little negative symbol to indicate that that's that it's lost, that it's gained an electron, and so it has a negative charge. So now we need to talk about ionic bonding. Ionic bonds occur between a metal and a nonmetal. And again, this is where one atom gives up its electron, or more than one electron, and another atom takes those electrons. Bonding occurs because the oppositely charged atoms attract to each other. Okay? So the opposites attract, and then the one that has one atom gives off an electron or more, and the other atom takes those electrons. And then again, each atom has a full outer electron shell after bonding. Okay, and so an example of an ionic bond is table salt, sodium chloride. Sodium, Na, which remember if we look at our periodic table, it's in that first group. Okay, so it has one valence electron in the outer shell. It gives chlorine, which if we look at chlorine on our periodic table, right, that's in the 7th period. So it has 7 electrons in its outer shell, so it needs 1 electron. So sodium gives away that extra electron that it has to chlorine, and chlorine takes it. So now they each have a full outer shell. So if you watch the video, see it's going to give the electron away. Right, so now that third shell disappears for sodium, and it gets filled in chlorine. So here it goes, right? So there it goes. So energy is being released. That element, that electron filled chlorine shell. Okay? And now they're attracted to each other because they're positive and negative. They attract to each other. Okay? And here's another one that you can see it. Right? And so now sodium has that plus sign because it's gotten rid of that electron. Chlorine now has that negative sign because it's taken that electron. So, if you look at the dog bones in this animation, they represent the electrons. Okay, so the dog comes and he gives his bone to the bigger dog. Right, now they're near each other. So that's an ionic bond. So some other examples of ionic bonding are iron oxide, which is Fe2O3, which is rust. Calcium chloride, CaCl2. So again, that means that we have 1 calcium, 2 chlorine, okay, atoms, and they give their electrons, and so we end up with a molecule. And potassium oxide. Okay. Now make sure that you go to Edmodo and complete the Edmodo quiz.